In this video, we're going to build on the last video and the idea of displacement, velocity, and acceleration. And we're going to look at a few formulas that'll be very helpful in calculating those. So first, let's just review from the last video. We had the idea of displacement. Let me just get my... Okay, we have the idea of displacement. And then we had the definition that velocity is equal to the change in displacement divided by the change in time, and so an example of that is 5 meters per second. And then we had that acceleration was defined to be equal to the change in velocity over the change in time. So that an example that might be 10 meters per second squared. And both these have directions, so let's say this is positive, and let's say this is negative, so it's going backwards. One interesting thing about acceleration is often if acceleration is positive, and if velocity and acceleration are both positive, we say that it's accelerating in terms of a car. Let's say your velocity is positive, so you're driving forwards, but your acceleration is negative, we would call that decelerating. So that's just a little connection there with some terms hopefully you're familiar with, but so we've got these two formulas, these two right here, and we've also got, there's three other formulas if we have constant acceleration, which are very helpful, and so those three formulas are the following. The first one is velocity final equals velocity initial plus acceleration times time. The second one is velocity final squared minus velocity initial squared equals 2 times the acceleration times the displacement. And then the final formula is the displacement equals time times the initial velocity plus 1/2 times the acceleration times time squared. Now these three formulas are for constant acceleration only. What do I mean by constant acceleration? Well, constant acceleration is, and I realize I wrote the three formulas and constant accelerations out of the screen, so let me bring that in here. Three formulas for constant acceleration. Constant acceleration simply means that your acceleration has to be a number, so a equals 9 positive, we'll say, moving to the right. A equals 9, or a equals 10, and that could be negative. Not a equals 10t, or a equals the sine of t, or some function. It has to be some specific number. And so these three formulas are useful in solving a variety of problems, and the general method we'll take to solve these problems is we'll see what we're given, what we need to find, and how we can get there. So let's look at a few example problems. So let's say you're given that velocity initial equals 2 meters per second, and and the time and the acceleration. So, and the acceleration equals 3 meters per second squared, so that's how fast the velocity is changing. And then they say at time equals 4 seconds. So 4 seconds later, what's the velocity final? So you say, okay, I'm given these guys. I'm given velocity initial, acceleration at t equals 4 seconds, and I need to find this guy. So we look for an equation that relates these, and so this down here brings in displacement. We don't need displacement. This one here again brings in displacement. This one though, velocity final, that's what we need to solve for. Velocity initial, acceleration time. This top one looks good, so we can just write out velocity final equals velocity initial plus a acceleration times time. And then when we substitute the values in, we have positive 2 for our velocity plus acceleration times time. So 3 is our acceleration, 3 meters per second squared times time, which is 4. Now the units for this are meters per second, and meters per second time meters per second squared times second is also meters per second, which equals, so 2 plus 12 equals 14 meters per second. That's velocity final, and we're done. Let's try, so that was kind of fast. Let's try another example. So let me scroll down here, and we'll try another example. So this time, let's say we're given that the acceleration equals -10, and let's say that the time equals 3 seconds, and this is meters per second squared, and velocity initial equals 0, and they want to know what is the displacement. So, and here instead of change in x, I'm going to do change in y, which hopefully that won't mess you up too much. Now, so what's the physical significance of this problem? Well, let's say that there's a little guy standing on the edge of a cliff, and he drops a rock, and the rock goes down. The rock's going to accelerate downwards with an acceleration of -9.8, or about -10 meters per second squared, so that's where we get our acceleration from. The time, and the velocity initial is 0 because he just drops it, and he wants to know how far in 3 seconds. So how far in 3 seconds? And so that's what this change in y is. This change in y, we're just going to use the exact same way we did our change in x. And so we've defined up as positive, and we've defined down as negative based on our acceleration. So what formula do we have that relates change in x or change in y, acceleration, time, and velocity initial? Well, the last formula I wrote was change in x equals time times velocity initial plus 1/2 a times squared. And so if we plug in our values here, this is our unknown, so, and actually it's change in y equals, time is 3 seconds, velocity initial though is 0 meters per second, plus 1/2, our acceleration is -10 meters per second squared, and then we're going to multiply that by seconds squared, so by 3 seconds squared to get meters as our units, meters, which equals, so -5 times 15 is -75. Is that right? So 9 times 10 is 90 divided by 2. No, it should be 45. 90, or 5 times 9. Yeah, I'm sorry. That should be -45. So we've got -5 times 9 is -45 meters. What does that mean? That means this distance here, and it's moving downwards, is equal to 45 meters. Now, and so this, hopefully this gives you an idea that this one-dimensional motion, it's true often things don't move in one dimension, but in terms of dropping objects that fall straight down, one-dimensional motion can actually provide a decent model for that.